We can, and must, use our curiosity and intelligence to look to the stars. We must do it now before humanity is overtaken by some disaster that we can neither anticipate nor control.
Hey everyone, Happy New Year. And to kick off the new year, I want to talk about something that's cheerful, and that's the potential extinction of all humankind. And in fact, Stephen Hawking mentioned this as one of probably the biggest threats that could be faced by humanity in terms of the devastation it could cause. And what's more, it's 100% certain going to happen. There's no debate about it. It's not if, it's when. What am I talking about? Has anyone guessed? Asteroids. Now, you may have seen films like Armageddon, and indeed another recent film released on Netflix called Don't Look Up, which is about a big 9-kilometer asteroid, comet actually, hurtling towards Earth, about the same size that did it for the dinosaurs, and how civil society reacts. And in these films, you typically see various things like nuclear weapons and astronauts flying off to the asteroids to try and deflect them from Earth. And what I want to do in this episode is examine the science behind those kinds of films, and is Earth actually prepared to deflect an extinction level event or a massive asteroid hurtling towards us? Because one day we will face that problem. Before I talk about the methods of potentially defending the planet, let's talk about the probability of it occurring. As I said, over time it's 100% certain we're going to get collided by a very, very big asteroid. And in fact, Earth suffers hundreds, thousands of asteroid collisions every year. You can see on this diagram here the number of different asteroid collisions that happen. One of the more notable ones in recent years was the 20-meter asteroid that hit Chelyabinsk in Russia, causing a lot of damage and a lot of injury. Actually, thousands of people were injured. And you can see from these pictures what just a 20-meter asteroid looks like. So you can imagine a 9-kilometer asteroid, what kind of devastation that might cause. NASA, through its own observation programs and the Planetary Defense Coordination Office, which is in fact a real thing, are documenting near-Earth objects above a certain size and above a certain probability of collision. On the screen now is something called the Century Risk Table, which documents those objects that have a greater than 0.2% chance of colliding with Earth. And you can see some of the members of this list are actually pretty sizable objects and could cause a lot of trouble were they to collide. And therefore, it's essential for Earth and humanity to design some kind of planetary defense system. And in films like Armageddon or Don't Look Up, you'll have seen some examples. And what I wanted to discuss now is, are these realistic? Is this actually how we'd do it? And how prepared are we to actually do it? Now, there are actually two ways that we would defend the Earth. First is kinetic and the second is nuclear. Since nuclear is the option that's discussed in all the films, let's deal with that first. In films like Armageddon, and in fact in Don't Look Up, the general hypothesis is you'd fire a bunch of nuclear weapons or drill nuclear weapons into the asteroids, blow them up into lots of small pieces, and humanity is saved. This, however, is generally not the preferred method for a number of reasons. Firstly, if the asteroid's very big, it takes a lot of nuclear tonnage in order to dissolve it into sufficiently small fragments. But second, because of the way in which the physics works, and recent research has shown that detonating an asteroid simply would agglomerate again into like hundreds and thousands of smaller asteroids, but still, as you saw from the Chelyabinsk photo, you know, a 20 to 50 meter asteroid, thousands of them, would cause also a lot of devastation. So it wouldn't really help Earth. The actual way of using nuclear weapons, rather than blowing them up into lots of small asteroids, is to try and deflect the asteroid. All methods of planetary defense rely on deflection. And the reason for this is because the nature of the orbit is that a small deflection or a small change in orbital speed can actually cause it to miss Earth. Earth, of course, being an extremely small object in astronomical terms. What's likely to happen, therefore, is instead of trying to blow up an asteroid in small bits, is that you would detonate some kind of weapon close to the surface, so a few hundred meters above the surface. That would irradiate one side of the asteroid, and as it was irradiated, it would push out dust and gas, and by virtue of Newton's third law, that would exert an equal and opposite reaction on the asteroid, therefore deflecting it off its course. So provided we had a few years of notification, which is exactly what NASA's doing right now, observing the skies, and you can see on the screen right now a map of all the near-Earth objects that NASA has so far identified. Provided you have a few years notification, it actually doesn't require too much of a change in speed. You're talking orders of magnitude 10 to the minus 3, 10 to the minus 4 meters per second, which is something that we could achieve with our own nuclear weapons right now. The second possibility for deflecting an asteroid is the kinetic option. By kinetic option, I mean we basically fly a satellite in and smash into the side of the asteroid, achieving the same result, deflecting it off its course such that it misses Earth. And in fact, NASA is currently, just recently, launched a satellite called DART. DART will head towards an asteroid called Didymos. Didymos is a harmless asteroid, it's about 700 meters in diameter. And around it orbits a small moon called Dimorphos. And DART will collide into this small moon, and then NASA scientists will measure how much it can deflect it by. And that would be, again, a very likely way of saving the Earth in future. There are, of course, other methods, things like gravitational pull, launching a very, very heavy satellite that gradually pulls, by act of gravity, gradually pulls the asteroid off its path. There are also things like irradiation, shooting lasers at one side, which works very similar to the nuclear weapons option. By irradiating one side, you gradually push it away through the virtue of radiation pressure. So, in conclusion, the big methods are not to blow the thing up, but to deflect it out of the way. And that's the most likely way in which we would be able to save Earth in future. The critical factor is time. You need to have enough years if the deflection method is to work. If, as in the film Don't Look Up, you only have 6 months, well, that's more problematic because you need a bigger deflection to turn it off course when it's already just a few months away from impact. So take a look at DART. The impact there will happen in 2022, this year, so it's pretty interesting in terms of the future of mankind. You can either watch the film Don't Look Up or some of the old classics like Armageddon. And now, armed with the real science, you can judge for yourselves how realistic you think those movies are.